All right, guys, the lesson today is really just a review lesson, but it's got some kind of nastiness to it. This is about rational exponents and your exponent rules in general. Okay, so the crazy rational exponent business just says that if you had like b to the 1/3, it really means the cubed root of b. Does that sound familiar? Yes, it does. Now, there's a part B that's a little more complicated. It says if you had, why do I not have a cursor? There we go. If I had like x to the 5/2, I can write that two different ways. Oh, I can write the square root of x to the 5th, or I could write the square root of x all to the 5th. All right, that didn't really go well on the notes right there because my cursor wasn't. Let me do one more example. If I had x to the 7/5 or something really disgusting, that is the same as the 5th root of x to the 7th, or I can write it the 5th root of x all to the 7th. It just means when you had something like this, you could take the cube root first and then square your answer, or you could square 64 and then take the cube root. I don't know about you guys, but I'd rather make it smaller first. What is the cube root of 64? Does anybody know? 4 times 4 times 4. Okay, so the cube root is 4. So then this would be 4 squared, which is 16. If you did 64 squared, you'd get like 256. And then you'd have to cube root that big number and we'd have more trouble. Okay, so it's just saying you can do it either order. All right, moving on. I got some slides off the internet about order exponent. Yeah, where's my works cited? Okay, stole this off Google. This is not news to anybody, I hope. When it says multiply, you add to the exponents, yes? When it says divide, you subtract the exponents. What would that one simplify to? If you just subtracted, you'd get this, which means this. We're good? Nobody's lost? And this one, if we had a 4 and a 3, it's not 4 to the 3rd, it's 4 times 3 is 12. Okay, so that's all review. But there's also one that some lists include. Does that look familiar? We just talked about on the first slide. Maybe it looks a little familiar. A over x, a to the x over y is the y-th root of a to the x, or the y-th root of a all to the x. Okay. Can I make fun of my mom on video? She always pronounces the H in W, in white. She always says white, and my kids make fun of her. White. All right, moving on. Those are just more examples. Let's start here. It says rewrite this in radical form. So what does this mean? 6th root of x to the 7th. Now, because we're in Precalc, we're going to talk about the fact that you have to simplify that. Okay. When you have the square root of 8, you say that's really the square root of 4 times the square root of 2, and the square root of 4 is 2, so you wound up with 2 squared is 2. Remember doing that stuff? And you didn't enjoy it then either, right? Okay. So if we had the square root of x to the 5th, you would say that's the square root of x to the 4th times the square root of x, which is an x squared times an x is any square root of x. Okay, you just want to cry right now? Yeah. Let me start over.
I mean, I wanted to cry before.
Okay. There's how many? We can take out every sixth, right? Sixth root. So if I rewrite this as an x to the sixth times an extra x,
that makes more sense.
The sixth root of x to the sixth is x. Then this guy that was all by himself, he's still in there. Sixth root of x. Another way to think about that, this will make sense to some of you. This is actually x to the 1 and 1/6. Yes? 7/6 is 1 and 1/6. So 1 is just an x, and this is a sixth root of x. Same thing. Okay, it's equivalent. Now, before I go any further, I'm going to talk about this slide. When you find an even root of an even power and the result is an odd power, you must use the absolute value of the result to ensure that the answer is non-negative.
I wouldn't think you say positive. Why not negative?
In other words, right here, when you took the sixth root of x to the sixth and got an x to the first, it's supposed to have an absolute value around it. Okay. No, I am not going to be picky about those. The answers in the back of your book, some of them will have absolute values, and the answers on the computer-generated answer key for the worksheet might have absolute values. I'm not going to worry about it, because we're not going to spend a lot of time on this, okay? All right, back to this problem. If I write this out, the 5 goes where? So I have the fifth root of 10n to the third. Okay. I would like us to talk about what that means. It means the fifth root of, what's 10 to the third? 10 times 10 times 10, which would be 1,000. And then what else? N to the third. Okay. Now, I don't want to confuse you. This does not simplify. But if you were checking whether it simplified, you would have to do fifth root. So 1 to the fifth is 1, 2 to the fifth is 32. Does 32 divide into 1,000? 3 to the fifth, I might need help. 243? Anybody doing 3 to the fifth for me? Does 243 divide into 1,000? Okay. 4 to the fifth, I think, is 1024. Okay. We're past 1,000 now, right? So none of those divided into 1,000 evenly, so it didn't simplify. All right. Moving on. This does simplify because this number is greater than 1, yes? So that's 1 and 1/3. So there's a 4x once and a 4x to the 1/3. That is equivalent to 4/3. So how would I write that as a radical? Some of you would have started out like this. To the 4th, okay? But that means there's 3 of them plus an extra one. So if I wrote this out, I would have cubed root of 4x 3 times with an extra 4x. So this takes care of that. Now, you could have done 4 to the 4th and then worried about simplifying it, but it would have been much messier. All right, this is a super easy one, guys. How would we write this? So you want 10 of those on the next quiz, right?
500 of them. Good easy point.
So is it any time there's something on the outside, it needs the absolute value?
That's a great question. Her question was, does this need an absolute value? The answer is no, because it's a cube root. Cube root can be negative. The rule said if you find an even root of an even power and you end up with an odd power. That's why I'm not going to worry about it, because it doesn't happen that often and it's very confusing. All right, this one is easier than we think. This is a giant square root around a 64n to the 6th.
You don't need to leave the rest.
The square root of 64 is 8. And what do we do with these exponents, really? Multiply. 1/2 of 6 is... Okay, because if we wrote this twice, it would be 8 times n to the 3rd times n to the 3rd. So square rooting undoes the sets of twins, takes these guys out, and makes it just an 8n to the 3rd. Okay. That's how I teach it when I start them with Algebra 1. We talk about twins. If you have any twins, like 5 times 5 times 2, one of these guys escapes, starts his life over as a 5. It's a twin jail. We just call it a twin jail. All right. What about this one?
8m to the 9th.
Okay, that looks kind of miserable. Okay. Can I talk about it a little bit differently? How about 8 to the 2/3? And what are we going to do with them on the variable? Multiply. So 9 times 2 divided by 3. Okay, got a little bit easier already, right? Now, what does this part mean?
8 squared, 2 squared.
Okay. Can we square it, cube root it first? That would be 2, squared would be 4. If we wrote it this way, squared, we'd have the cube root of 64, which is also 4. So it doesn't matter what order you do it in, okay? So this became 64m to the 6th. If we had done it here and squared it all first, we'd have had the cube root of 64m to the 18th. The cube root of 64 is 4. What did I do? This is supposed to be a 4. Yeah, thank you. This is a 4, and then we divide this by 3 and we get m to the 6th. Okay, so I did it like 4 different ways, and eventually I got the same answer. Sorry, I wrote that one wrong first. Okay, don't hate. I know some of you hate on me when I start doing stuff more than one way. It's confusing, right? Okay, what can we do here? Just multiply. What's 6 times 3 divided by 2? So we have x to the 9th and we're done?
Yeah.
Okay, this is 343 to the 4/3 times n to the, what happens when we multiply those? 6 times 4 divided by 3? Okay, n to the 8th. Is this a perfect cube, guys? The cube root of 343 is 7, and then what do I still have to do? To the 4th power, right? I don't know what that is. 2401?
Yep.
I only know that because I've done this lesson 3 times today. 2401 n to the 8th was our answer. You could have typed 343 to the 4/3, and because it came out nice, your calculator would have done it. Okay. All right, number 9. These directions say that you can leave things with fractional exponents as long as they're not in the denominator. It says your answer should contain only positive exponents with no fractional exponents in the denominator. What they're saying, guys, if you have this, that's really 1 over the cubed root of n, which is not okay, right? Can't have radicals in the denominator. Now, yeah, I'm with you. Why is that even a rule? I agree. But can we talk about this one real quick? People want to cube the top and the bottom to get rid of that. That changes the number, right? If I take a random number and I decide, oh, I'm going to cube the top and the bottom, that changes the number, okay? The only thing I'm allowed to do is multiply by a form of 1. This gets a little confusing. Okay, do this easy example before we get to the hard ones. What you're going to do is multiply by 2/3. See if that makes any sense. Now there's how many down here? Yes, there's an n to the 3/3 in the denominator and an n to the 2/3 in the numerator. This is 1, so I end up with the cubed root of n squared over n. This is equivalent to this when you get rid of it. And according to the directions, we could have left it n to the 2/3 over n.
Why don't you just do 1 over the cube root of n times the cube root of n over the cube root of n?
Okay.
Is that just square root to it?
Yes. That's the problem, is you'd have to do it again so that you wound up with the cube root of n cubed down here, and then you'd wind up with a cube root of n squared, and this would go to an n, and that is what we did, okay? You'd have to do it 3 times. Great question. All right, guys, we don't get to any of that messy. There's only 2 on the whole thing, and I'm raising my right hand, okay? I do hereby solemnly swear there's not an icky one like that on a test or quiz. But we're going to do just a couple of easy ones like that together. Back over here, order or exponent rules. I can rewrite this in any order I want, yes? Because it's all multiplication. Does everybody understand that that's all multiplication? So I'm going to put those big fat coefficients out front. Then I'm going to put my x's next to each other. And then I'm going to put my y's next to each other. Just in a way to explain it a little better by writing it like that. Because what's 2 times 3? 6. How many x's do I have in here? X to the 3rd or an x cubed. Everybody all right? What do I do with this mess? What did you do with these exponents? Added them. So we need to add those. Okay. You can go 4/3 plus -1/2 on your calculator. I'm going to be a math teacher and get a common denominator. So I'm going to make this 8/6. This with a common denominator would be 3/6. So what is 8/6 minus 3/6? So I have a y to the 5/6. Did anybody try it on their calculator and get 5/6? Yes. Okay. The direction said I don't have to write it as a radical. I can leave it as long as I have only positive exponents and I don't have a fractional exponent in the denominator. That means if the whole thing is over something with a fraction, okay? You can have like a fractional exponent here, as long as there's not over something else. All right, so I don't know if we can squeeze this little one in here. We can try. We have a 2 and a 4, which give us what? 8. We have an x to the -1 and an x to the 5/3, which is actually -3/3 and +5/3. If we add those, we get what? 2/3. Everybody okay? And then we just have a y to the 3/2. I mean, it doesn't say we have to do anything more.
Can't we simplify the y with 3/2 if we wanted to?
How?
What if we y times y squared?
It would be y times y to the 1/2. but then we'd have to do something with this one too. Yes, this would be, this is 1.5 y's, right? So we'd have y times square root of y, but then we'd have here a cubed root of x to the third. Or, no, a cubed root of x squared, I'm sorry. And then we got square roots and cube roots, and, oh, I don't think we want to go there. Let's just leave it with fractional exponents. We'd have to get a common denominator, put them in a common fraction, a common radical. Okay, it's making us want to cry a little, right? Okay, what are we going to do here? Now, everybody all day has said distribute. We do need to take this and apply it to both of these things in here, but it's really not called distributing, guys. If you were distributing, you would have to have something like this. You're multiplying across addition or subtraction, okay? This is just taking the 3/2 and applying it or multiplying it by each of those. Are you okay with that? So if it said this, you would say m to the 10th, n to the 15th. You could say I'm going to multiply the exponents on both of those, or you're going to say I'm going to apply that 5th power to both of those, but it's really not called distribute. When you say it, I know exactly what you mean, and I know you're going to get it right, but I'm recording this, so let's not say it, okay? It's not called distributing. All right, guys. So 3/2 gets applied to this, and 3/2 gets applied to that. And then we have an x squared and a y to the -2. All right, what's -2 times 3/2? What's 2/3 times 3/2? 6/6, which is 1. Everybody okay? And then we have an x squared and a y to the -2. Now what?
Now you gotta
Add these exponents. We get x to the -1. Add those right there and right there. Add those exponents on the y's, and I get y to the -1. It said I can't have negative exponents. 1 over xy. Everybody okay? That's about the hardest I would ask on a test or quiz. Could you get that one right?
Yeah.
I hope so. This one's easier. Just multiply. Be careful. What's 5/4 times 3/2? 15/8. So we have a v to the 15/8 times a u times a v to the 3rd. Common denominator. Yeah, this would be times 8/8 would be 24/8. So we'd have 15/8 plus 24/8. Did anybody use their calculator? Get 39/8? Yes? No? Try it. 15 divided by 8 plus 3. Math, enter, enter. Is it working? 39/8. And then what do we still have? A u. I'm going to go ahead and write it out front so it's alphabetical order, but it doesn't matter. Yeah, it was really nice outside when we went out for that fire. Did you want to stay outside? I totally wanted to stay outside. It was gorgeous.
Oh my god, can we just go outside to see?
This isn't even my pencil. I keep dropping it.
No, but it was a great idea. Okay, let's finish this question. What's going here? Let's start back here. What do we get?
That'd be
-2/4, which is -1/2. Okay. Nothing to add to the 5/3, but what do we have to do with these on the v's? 4/3 plus -1/2 would be 8/6 plus -3/6. How did I do on my common denominator? 5/6? Anybody do it on the calculator and get 5/6? Okay. Are we done? Nothing else we have to do on that one though, right? We didn't end up with any negative exponents or anything? Okay. Everybody okay? All right. we have to apply this to both of these. What are we going to get down there? We have a u on top and a v to the 3/2. And on the bottom, this will become what? 2/3 of v to the negative 2/3. And back behind there was a u to the 3/2 and a v to the 4/3. Okay. Don't cry. It's okay. We can do this.
Why does this even exist? Like, it shouldn't.
This is one of those situations where I ask you, like, when you live, or you use this.
Yeah.
What am I using in my life?
Not so sure about this one.
Except
It does. Okay, guys. It relates to exponent problems. It relates to logarithms. Do you remember logarithms? Guess what the chapter after 2 is? Okay.
3.
Logarithm rules undo these, so they're the opposite, where multiplying means we add exponents. In logarithms, when it says to add, we multiply. Okay. So we got to know it for that. All right. Let's get these combined down here. Can you add those exponents for me? 2/3 plus 3/2. Be careful. It's 4/6 plus 9/6, I think. Is it 15, 13, 6? Did someone use a calculator? Okay. So we got u to the 13/6 down there. And let's add these together. Oh, I can do that one. Negative 2/3 plus positive 4/3 is 2/3. Okay. On the top, we had still a u and a v to the 3/2. Now what?
Now cry a little bit.
Okay. Remember way earlier in the lesson I talked about we had like a v to the 2nd over v to the 5th, and we wound up with a 1 over v to the 3rd or something? We got to subtract, and if it's negative, turns out negative, we leave them on the bottom. Okay. So the u's would be a 1 minus 13/6. What is that going to be? Negative 7/6, which just means it belongs on the bottom. Okay. So we have 1 over u to the 7/6. Okay, that's going to be a problem because we can't have fractions in the denominator. Okay, finish this. Finish right here. The v's, what happens to the v's? 3/2 minus 2/3 is 9/6 minus 4/6 is 5/6. Oh, where is it though? It's top though, right? Started right in the wrong spot. Okay, v to the 5/6. Okay, I'm kind of out of room, but I'm going to keep going here. Okay, we need this to be a whole number, divisible by 6.
1. No, -1.
The v down, the u down here, how many more do we need to add to 7/6 to make it divisible by 6? 5/6. Because then we'd have 12/6, which would be 2. Whatever we do to the bottom, we have to do to the top. So now we have a u to the 5/6, a v to the 5/6. I just wrote them in alphabetical order. And on the bottom, we have a u to the 12/6 when we add those, which is? Okay. Now, before you cry, let me show you the answer and see if we got it right. Do you remember? Did everybody write it down? Okay. Let's see. Is this what we got? U to the 5/6, v to the 5/6 over u squared. Okay. Let me explain why that's better. Because there's no radical in the denominator. If we rewrote the top, we'd have this. And that's kosher. There's no radical in the denominator. And I already swore I wasn't going to put one like that on a test or quiz, okay? Last two like this. And then we're going to talk about some examples out of the book work. But what number are we on? 15. Okay, 15 is a better one, I promise. What do we want to do?
Flip everything.
Do you want to flip everything?
No. Negative exponent.
We can flip everything, or we can just multiply all the exponents by -2 and then decide where they go. It doesn't matter to me. Okay. If we flip it first, we end up with an x, y to the -2, x to the 5/4 over x squared. But we didn't get rid of the exponent yet. What did we make it into? A +2. So now we still have to do what?
X squared.
So this 2 is going to go to multiply to all the exponents. So we get an x squared, -4th, 5/4 times 2, which is, okay, all I did was flip this totally upside down. I didn't do anything else. And I changed it to a +2. Now I'm taking this 2 and multiplying it by everything. I'm just doing the order someone suggested. This isn't the order I would have suggested, but that's fine. I'm proving that it works. Okay, and down here we get an x to the 4th. What do you want to do next? You can move the y to the 4th down here. Now what? Yeah, could we just get rid of this one and divide this one down to 2? That's nice because we don't have any fractional exponents in the denominator, right? Oh, but we still need to subtract those. What happens? 5/2 minus 2 is? That's supposed to be a y to the 4th. I didn't write it very well. I'm going to go back to the original problem really fast. Guys, just put your pencil down and watch. If I had multiplied those exponents, I would have had a -4. Down here, I would have had a -2, a y to the +4, and -2 times this would be -5/2. That's an x. Thank you. All right. Then I could have decided to move some of them. Move those 2 up there, those 4 down there, leave the y's, move these up top. Okay. Then I could have added the top. 2 and 5/2 is 9/2. Then I could have subtracted the x's. This is 4.5 minus 4 is 1/2. Okay, did a totally different order. Did I get the same answer? Yes. All right. This one's icky.
Great.
It doesn't start out too bad. Just at the end, we have one icky step.
Junior year in a nutshell. Doesn't start out too bad.
Can we multiply those together? What do we get? 4 times 3/2.
4 times 3 is 6.
Okay. What do you want to do next?
Let's make that y go to the bottom.
Okay, put the y on the bottom.
Oh, it doesn't matter anyway because it's a freaking fractional exponent.
Okay. Yeah, that's all right. We'll deal with it in a minute. Do you want to add these to the top? Add the exponents up there? What's 2 plus 3/2?
You get rid of the on the bottom.
7/2? Now what though?
You multiply by there's 3.5 on the top. There's 6 on the bottom. So 2.5 on the bottom.
If we subtract exponents here, 7/2 minus 6 is actually minus 12/2. We get -5/2, which means there's 5/2 where? Okay. So if I was a really nice teacher, I'd let you stop right there.
But you're not.
Okay.
I'm just kidding.
Just checking. I'm not nice. No. I told you I'm not going to put this on the test. There's the nice part, okay? We need to figure out how many more to make this a whole number. 5 out of 2, we need 1 more half, right? Everybody okay? Because that'll make 6/2, which is 3. But if we do it to the bottom, we have to do it to the top. How many more y's do we need down there? We need another half a y, which is another half to the top. So how many y's will we end up with on the bottom? Half and half is 1y. So on the top we have an x to the 1/2, y to the 1/2. And in the denominator we have an x cubed and a y. Let's see if that matches their answer. Is this what we got? X to the 1/2, y to the 1/2, x cubed, y? Okay. The reason for that, one more time, is if I wrote that as a radical, I'd have the square root of xy over x cubed y. Is that kosher? No radical in the denominator. All right. Please don't pack up. Give me a second. This is off the homework out of the book. This is not nice. If I wrote this as 32 to the 1/10 over 2 to the 1/6, there's still nothing I can do. The trick is that 32 is a power of 2. Yes, Basma recognized right away that that's 2 to the 5th. Now what can I do because they're powers of 2, guys? What's 5 times 1/10? And what do we need to do then? Subtract. So 3/6 minus 1/6 would be... Did I do that right? 3/6. Okay, which is 2 to the 1/3, right?
Yeah.
Which means I could really write it as...
Two. Boom. Drop the mic.
Okay. I'm going to do one more because this is on your homework. You did this last year. 4 goes into 21 5 times. 1 left over. 4 goes into 15 3 times with 12, 13, 14, 15, 3 y's left over. This is how you could have done that. Okay. This becomes an x to the 5th with a 1/4. This becomes an x to the 3rd. That's 12 with a 3/4, right? Oh, that's a y. Those are both y's. Just kidding. All right, so then we have an x to the 5th and a y to the 3rd, and then these 4th guys need to go back in the radical. It's the 4th root of an x, y to the 3rd. Can anybody do this one really fast then? We have a 5th root. How many are going to go in here? 1 goes out and 1 left over. 1 in, 3 left over. 2 out, none left over. 2 out and 3 left over. That's right off your homework.